Welcome to Properties of Matter, video 1-2 for Mr. Lawrence's chemistry class at East Central High School. In this video, we're going to look at matter. We're going to understand what matter is and the different kind of properties and the changes that can occur in matter. When we talk about matter, we're going to be using these different vocabulary terms. Many of these terms may seem familiar to you as you probably used a lot of them or learned a lot of them through your middle school science classes and even in biology. Throughout this video lessons, I will use these vocabulary terms within the lesson. And if any time you are unclear about any of the terms, pause the video and take a minute to Google or look up the definition of these terms. So when we talk about matter, the basic definition is matter is anything that has mass and takes up space. Everything in our universe that exists is matter. Well, almost. Energy, and anything in the supernatural, that is not matter. But everything that you can touch in your hands or that you can measure is matter. Yes, even you are matter, Albert Einstein says. You are living, you occupy space, you have a mass, so you matter. But what are other examples of matter? The chair you are sitting in, that is matter. The Chromebook you are holding, that is matter. The air you are breathing, even though you cannot see it, that air does take up space and it does have a mass even though it's small. So as we keep using this term mass, the question is, well, what is mass? Well, mass is simply the measurement of the amount of matter there is. Consider a glass of water. If it's a 5-ounce glass of water, that has a certain mass. If it's a 10-ounce glass of water, it has a different mass, which would be greater than the first amount because there's a more amount of water in the bigger glass. As we continue to think about matter, we understand that matter is broken up into things called atoms. Atoms are the smallest unit of any element that exists. Atoms are the smallest unit of anything that exists in our universe that is matter. So when we say an atom is made up of protons and neutrons and electrons. The reason why we say this is the smallest unit of an element is because each atom has a specific number of protons, neutrons, and electrons. In fact, we will find out that the exact number of protons an atom has is actually how we identify which element it is. So when we use the term element, that is used to describe what kind of atom we're talking about. An element is a pure substance made of just one type of atom. Remember, again, atoms are protons, neutrons, and electrons, and depending on the number of protons is how we identify what element is what. For example, if you look at a periodic table, hydrogen has one proton. Therefore, the atom with just one proton is called the element hydrogen. Oxygen, it is an atom that has 8 protons. So whenever 8 protons are clustered together, that atom is classified as the element oxygen. Here to the right is a picture of water. Water is an example of a compound. A compound is simply when 2 or more atoms or substances are added together. So in this case, we have 2 hydrogens here attached to 1 oxygen. Since there's 1, 2, 3 atoms here, we would call this a compound. So everything in our world, every piece of matter in our universe or in our planet is made up of an atom or certain kinds of atoms. Those atoms are all classified as elements. And when we combine atoms together, or even different atoms and different elements together, we get what's called a compound. So now we can start to consider what are the properties that certain elements have, or certain types of matter have. The first 2 classifications we have are extensive properties and intensive properties. Extensive properties is a characteristic that we can observe or measure that is dependent on the amount of matter. Intensive properties are characteristics that we can observe that are not dependent on matter, but are actually have to do with the intrinsic values or intrinsic characteristics that that piece of matter has. So down below, we see this little table. We see that we have sulfur here. We have it in a crystal form and we have it in a powder form. Extensive properties here would be things like mass. This sulfur crystal weighs 39 grams. This sulfur powder weighs 0.84 grams. So we could classify the mass here as an extensive property, just like the volume, the amount of space it takes up. An intensive property are things that are true no matter how much of that substance you have. So what is true about this and this? Well, it's true that they're both yellow. Therefore, those are intensive properties. It is also true that these two have the exact same melting point. Means if we want to turn these into liquid at the temperature 115.2 degrees Celsius, both of these would turn into a liquid. So if you want to keep these straight, think of intensive properties as things that are inside characteristics. What are features, what are properties, what are characteristics that a substance have that are true no matter what you do to the property on the outside? We can also classify matter as physical properties and also chemical properties, we'll see in a minute. Physical properties is a property we can observe without changing the chemical makeup of that structure. Let me say that again. Physical properties is something that we can measure or observe without changing that chemical. So consider water. Water can be a liquid, water can be a solid, water can be a gas. The property of it being hard or fluid or vapor-like are physical properties because we can observe and we can measure those, but yet in all the stages, they are still a physical property. That's why melting point or boiling point are considered physical properties. The measurement of what those are, because we can do these procedures to them, but yet at the end of the day, it's still water, whether it's a solid, liquid, or gas, and the measurement of the actual melting point or boiling point are still considered physical properties because they are true to that chemical. So a physical change then is when we can manipulate or alter that substance, but yet even though it changes, it is still the same chemical. And again, the example is if I have water, if I have H2O in the example of water, I can freeze it even though it changed physical phases. It went from a liquid to a solid. That was a physical change because it is still water at the end of the day. So the opposite of that would be chemical properties. Chemical properties are things that we observe within a piece of an element or a compound, but these characteristics change due to the chemical nature of that substance. So whenever a chemical changes colors, or maybe if it is changed into something completely different, we observe chemical properties. Often chemical properties, you can observe them as color changes, but they are the ideal of what happened that changed because what one chemical was once there is now a new chemical. So the process of a chemical change is where that chemical was actually transformed. So now let's look at rust coming from iron on an atomic level. Here we can see these red circles represent iron. Iron is one kind of an element with a certain number of protons that happens to be 26 protons in a cluster. So this red circle represents 26 protons clumped together. And I have a big chunk of iron here. But what happens to iron is it is exposed to oxygen. When it's exposed to oxygen, it's going to undergo a chemical change. That chemical change is happening because what once was iron is now reacting, it's having a chemical reaction with oxygen, and now we are creating iron oxide. Therefore, that is what rust is. Rust is iron that's been oxidized, and so the red flakes on here is actually a new chemical, iron oxide, hence why the chemical change happened, because what once was iron is now a different chemical called iron oxide. So let's practice this together real quick. Let's try to think about a piece of paper, and let's try to apply a thought process to decide if that paper is undergoing a physical change or a chemical change. So we have a piece of paper. Let's say that piece of paper, I tore it up. I tore it right down the middle, I shredded it up a little bit, and it's still sitting there as a piece of paper, but it is just clumped together in shreds. Was that a physical change or a chemical change? Take a guess. That was a physical change, because even though we changed the shape of the paper, it is still fundamentally paper. It is still there. So when we go back to the idea of what a physical property is, it's observing or measuring something, or it's changing something where the chemical is still the same. Now let's consider that same piece of paper, but instead of shredding it, I'm going to light it on fire. I am going to burn it. So now after I burn that paper, what once was paper is now a different chemical. So was that burning the paper a physical change or a chemical change? You would be correct. Burning paper would be a chemical change. Now, what was a chemical property that I observed? Well, I could observe the color change. I could observe how it became black. That color change would have indicated that a chemical change occurred. Think back to the piece of paper that was just shredded. If you observed it as now shredded into small pieces and it changed shape, that would have been a physical property. The shape or the volume of it has now changed. Even though it's still paper, we did change the physical property about it because we took it from being a sheet to now a pile of paper shred. So let's move on and consider now the different phases in which matter can exist. We have solid, liquid, and gas. The fourth phase of matter is plasma, which we won't deal too much in this class, but it is important that we'll get to it down the road. So when we think about liquid, solid, and gas, it's important to understand that any element, any atom, any piece of matter in the universe can exist as either solid, liquid, or gas. The difference between these three things are not what type of chemical they are, not whether they are solid, liquid, or gas. It doesn't depend on if they're a metal or a non-metal. It actually just depends on what's going on with the molecules inside that piece of matter. If the molecules or the elements or the atoms are brought tight together, it's called a solid. And a solid is defined by something that has definite shape and a definite volume. If I put a cube down on the corner of my desk, it is going to hold its shape. That Rubik's Cube will hold its shape. A liquid is defined as something that has definite volume, but no definite shape. A glass of water. It will take the shape of any container it's in. And then we can consider a gas. A gas is when the molecules are spread out the furthest apart, and they still exist, but because they're so spread out and because they're able to move fluidly, we see that there's no definite shape and there's no definite volume. That volume can be compressed, that volume can be expanded, and it is going to be ever moving. And those are the three states of matter that we'll deal with. So as we're moving on and we begin to think about matter, we can start to classify matters into certain types. We already know that they could be understood as atoms or compounds, and they can be classified as elements depending on what kind of atom it is. But now let's start talking about compounds. How can I classify compounds that are grouped together? When we start talking about grouping things together, we are going to start using the word mixture. A mixture is when we blend two or more types of matter together. This can be a blending of elements, of atoms, of compounds, or even of two other solutions that may be out there. So an example of a mixture would be seawater. Seawater is going to be salt in water. So the sodium and the chlorine are salts, but when they go in the water, they don't actually react with the water. They just simply intermingle with it, and you have water, salt, water, salt, water, salt, water, salt, hence making a mixture. Think of this, or the term for this would be, if we're going to classify it beyond just a simple mixture, now we can classify it as homogeneous, or some people say homogeneous. I like homogeneous. I'm a hick from Southern Indiana, so I'm going to say homogeneous. So if something is homo, the word homo means the same. So if we have something like seawater, it is a mixture, but we can be more specific and call it a homogeneous mixture. Why? Because if I have a glass of seawater or a glass of salt water, it is going to be the same throughout. The salt water on the top of the beaker or the salt water at the bottom is still going to be water, salt mixed together evenly. But when we come across something that is not mixed together evenly, we're going to call that heterogeneous. And this is when it's not uniform. It's not the same throughout. Think about putting a piece of clay in water. Putting clay in water is different than putting salt in water. The clay will not break down, the clay will not dissolve, the clay will not mix well with the water. So even though I'll have a mixture, I'll have a blend of clay and water, we would classify clay and water as heterogeneous. and cottage cheese too. Some people call this chunky. Some people call this the chocolate chip cookie, where you have just an inconsistency within whatever you are talking about. Here again, when we're looking at the molecules, a homogeneous mixture is when different molecules or compounds are spread throughout evenly. They don't technically bond chemically, but they are just mixed evenly. Heterogeneous mixture is when you have different molecules together, but there's obvious separations. Again, this could be a liquid, this could be a gas, this could be a solid. Whatever kind of mixture you have, if it's uneven, we'll call it heterogeneous. If it's evenly mixed throughout, we'll call it homogeneous. Now, another way we can classify matter is what's called a pure substance. A pure substance is something that has a fixed composition or a definite composition or an exact composition. Now, if an element is just one type of atom, let's look at this circle here. Let's say this right here is all just sodium. If this was a chunk of sodium and had all these different atoms of just sodium sitting there, it would be a pure substance because it's still just one thing together. It's a pure substance. Let's say I had sodium chloride here. Sodium and chlorine were bonded together, and now this was a pile of salt. Even though it's a compound, because sodium and chloride are bonded together chemically and it's consistent throughout, it would still be considered a pure substance because it is chemically bonded and it is chemically one unit, but just millions of those units together. That's slightly different than a mixture because here we have things spread throughout, and because they are still intermingled, they are not chemically bonded here. They are just simply being suspended by each other, and that's why this is called a homogeneous mixture and not a compound or not a pure substance. A heterogeneous mixture, again, is when I have two different kind of chemicals that are mixed together, but they are not chemically bonded. So the idea in a compound is they have to be chemically bonded, and if it's consistent throughout, it's considered a pure substance. A mixture, however, is still things mixed together. If it's evenly mixed together, it's called homogeneous because these guys are not chemically bonded together. You can think of like red Kool-Aid, sugar, and the food dye is not bonded to the water. It's just simply mixed evenly throughout, and it appears to be one unit. And heterogeneous, again, is things are mixed together, but it is not consistent throughout. So one thing that helps you understand these is this flow chart. This flow chart might help you process it, but again, don't emphasize too much on being able to classify. You practice this a little bit, and once you kind of get used to it, it really becomes kind of understood. But this flow chart will help you. If you have a piece of matter, let's start with gold. I have a chunk of gold. Is it matter? Yes, it exists. Can it be physically separated? Can each piece of gold atom that is stuck together in that chunk of gold be separated? And the answer would be no. It is just gold. You can't separate the gold from itself, because if you do, you would still have gold. So therefore, it's a pure substance. So now we ask ourselves, on a chemical level, is that gold being bonded to something, or is it just simply gold by itself? Since it's simply gold by itself, we would consider gold an element. It is an atom with a certain amount of protons, and it is a pure substance. Now let's go back up here and let's look at Kool-Aid. We have red dye, sugar, and the water. Is it matter? Yes, it exists. Can it be physically separated? The answer is yes. If you wanted to separate water from the sugar and the red dye, you could do that using physical change. How? Well, let's say we boil the water out. If I boil the water, it's going to go from the physical state of solid to gas, and left behind will be the physical evidence of sugar and red dye. So yes, I can separate Kool-Aid physically. So now it's going to be a mixture. But now I got to look at that Kool-Aid. Is it uniform? Is it the same throughout? And the answer would be yes. If you stir up your Kool-Aid well enough and you put the right amount of sugar in there, you don't overload with sugar, it is going to be consistent throughout. Since it's consistent, we think of the word homo, and therefore it would be called a homogeneous mixture. And another term for that is solution. Colloids and suspensions, we'll talk about later. We'll experience some of that in the lab. But right now, this is the basic idea of how to use this flow chart. So I hope that this video was informative. If you kind of dozed off, here's the key things I want you to know. Atoms make up the whole universe. All matter in our universe are made of atoms. Those atoms can be classified as different types of elements. Remember, atoms are just protons, neutrons, and electrons. And all matter, whether it's a compound, whether it's an atom, they have unique and different properties and characteristics. Some can be physical, Some can be chemical properties. Some could be intensive properties, and some can be extensive properties. And the other idea is matter comes in a variety of forms. It could be a solid, liquid, or gas, or matter could be homogeneous or heterogeneous. It could be a pure substance. It could be a compound. It could be a element. So I hope now you can understand a little more the difference between properties and the changes that can occur in matter. I hope now you have a foundation to begin to evaluate matter by the type of properties it have, which you'll be doing in your homework and in your lessons. And I hope also now you have a leg up in being able to determine different types of matters. Have a great day, and I'll see you soon. Goodbye.